Hey folks, I'm back. So we're talking about climate change. Um, it's important here to distinguish between climate and weather. Weather is sort of what happens every day, right? So weather is highly variable. So some days we have rain, and some days we have snow, and some days we have sunshine, and some days it's warm, and some days it's cold, and some days it's medium, right? And and certainly it's seasonal. So there's a cycle based off our position relative to the sun because of axial tilt. Um, uh, but but at the same time, um, you know, so there's what we get on a particular day based off winds and moisture in the air and season. Um, but we also can talk about the overall climate, right? So the larger average that we might get here. So I've been here 20 years now in Bowling Green. I've lived in Kentucky most of my life, other than the period that I was in grad school. Um, you know, for the most part, I can count that we're going to have probably, um, you know, in a regular year, what, uh, two or three times that we might get um, uh, below zero for a couple of days. Maybe two or three times a year that we might get snow that sticks and causes everybody to shut down things. Same time in the summer, we might get two or three periods where maybe 2 or 3 days where we'll have temperatures over 100. But we don't, those are sort of the extremes that we tend to face here. But for the most part, on average, the climate here is pretty clement, right? It's pretty even keeled for most of the year. And so when we think about the long-term climate of Kentucky, it's, we can look at the general averages, highs and lows of this back now, as long as we've gathered it for about 100 years, probably a little bit more than 100 years, and we can see what the general climate is on average. And we look at those average temperatures yearly or in a 5-year trend, right? What we notice if we do that sort of thing is that while the weather has, still we have a couple days that are really cold, a couple days that are really hot. The hot days are tending to trend up a little bit, and the cold days and the amount of snow that we've got, well, at least the cold days have gone down. Again, given climate change and the idea that we might get more precipitation, so you might argue that the cold events that we do get, where we get a lot of snow, we may get more snow than we would have seen in the old days because there's more moisture in the air. So again, climate is going to be those long-term trends. Weather is going to be what we get day to day, and weather is going to vary a lot more than climate does, right? But a lot of things people say, well, it's still cold weather, so global warming is bullshit. And I'm like, no, global warming is not. It's the likelihood that we're going to see hotter days, warmer temperatures than colder. One climate scientist talked about the idea of loaded dice, right? That in a state like ours, I could roll this dice and maybe color ones and twos as being cold days and threes and fours as being medium days and fours and fives and sixes as being extremely hot days. And I could roll the dice and it'd be random, right? We'd have either cold, hot, or medium. But as we change the climate, as we put more CO2 in the atmosphere, more methane, more other greenhouse gases, what we're doing is changing the odds. So we're making it so that fours come up hotter days, and twos come up medium days, and maybe cold days only come up on ones. So we're loading the dice by our activity. Now, that doesn't mean that random variation still doesn't occur. It does. And there will be some cold summers, and there will be some, but there's probably more likely to be hot days than not. That's the nature of changing the climate. Right? The single most important cause of climate change is the accumulation of carbon dioxide and other gases in the atmosphere. Carbon dioxide tends to be released. It's released by a number of things, but in part it's released by burning wood, by burning coal, by burning fossil fuel, combustion of any form releases carbon dioxide. Methane gets released through decomposition. It's another carbon compound. Fertilizers contribute to the buildup of the CO2. Fertilizers have carbon dioxide in them. A lot of times that is, again, manure. So manure is both going to have methane components and carbon dioxide components. And all that material, as it outgasses and ends up in the atmosphere, again creates a barrier that traps heat in the atmosphere and causes the Earth's temperatures to rise. Like the greenhouse. I'm sitting in a sunroom. This morning, I had closed the sunroom off. This is sort of an outbuilding. It's my studio here. And I turned the heat down, and the heat in this room was 4 degrees higher than it was in the other room next door. And it was 4 degrees higher because the sun was coming in this area and heating up the air in this space. Now at night it's going to be much cooler because it's going to release, but it's or a little bit cooler. But like a greenhouse, right? It traps heat. On average, the Earth increased its temperature by 1 degree Fahrenheit in the 20th century, given what we had started throwing into the air with the rise of the internal combustion engine and what we had done in the 1890s with the rise of coal mills and our industry. And so these small changes that have increased the temperature, and that temperature increase is already having oversized effects. So, and again, these effects are being tied to climate change. Again, sea level rise from the melting of glaciers, snow and ice. That has an effect on the level of reflection of radiation back out into the atmosphere. If you look up in the night sky and you see Mercury or Jupiter or Saturn in the sky, they have different brightnesses. In part, that is called albedo. Albedo is the level of brightness that reflects off a surface. And if a surface reflects back a lot of light, then it doesn't get as warm, right? So there's a difference if you wear white clothes in the summer versus you wear dark clothes in the summer, right? Dark objects tend to absorb more heat. Light objects that tend to, again, have a higher albedo, and so they reflect back a lot of the energy that the sun hits the surface, right? And what happens is with snow and ice, it has a higher albedo. So, and grass and green area, right? Mud, brown, is going to have a less of an albedo, and so it's going to accept more of the sun's warmth, right? And that's going to lead again to increased temperature, right? And it will lead to more loss of snow and ice, right? Increased temperatures in the ocean, which also causes sea level rise. we'll also have a change as waters evaporate in some areas in the sea. That will increase acidification. It'll change the chemical the amount of chemicals diluted in the water, the types of chemicals diluted in the water, and may make things more acidic, which affects things like reefs. So the bleaching of the Great Barrier Reef, the bleaching of other undersea reefs have an effect. The increasing vulnerability of coral reefs is a factor here. Decreasing plant and animal biodiversity in many ecosystems. So again, trees are, as climate change occurs, you could say, well, animals can just move to a new area because so if the geese fly south over the winter, they want it to fly as far. They can winter up closer, and then they fly north. They can fly even further north. The issue is that each animal is adapted to a bioregion, is adapted to it's an environmental niche, and that may mean that it's adapted to certain trees and certain food sources, and trees can't migrate very fast, right? They don't. An individual tree doesn't migrate at all, but certainly its seeds can migrate. But that may mean that a particular species of tree may only migrate a couple of miles a generation, right? That's probably slower than what is necessary for to keep up with the changing climate of a region, right? So as animals and plants, especially plants, don't migrate as fast, right? Animals that can't adapt to new food sources, can't adapt to the changing climate, are going to suffer, and so we'll see potentially increased loss in plant and animal biodiversity as animals, the food niches, the food sources that animals tend to rely on, can't move to new places, to new areas. We'll see changes in ocean currents and wind patterns as different parts of the Earth's surface, again with loss of ice, that'll change the amount of warmth in particular regions of the ocean, particular changes in warmth in particular areas on the Earth's surface, and that may change wind patterns. That may change ocean currents. That can have even further effects on places like England and Ireland, which sit in the it's not the jet stream, it's the current out of the Gulf Stream, right? That those land masses in Europe, the water around them comes out of the Gulf Stream, is warmer than other water in the region, and that affects their climate. And again, the rising in climate change might affect the Gulf Stream, right? And that would have potentially catastrophic effects on England, on Europe. Imbalances of hydrological cycles, drought in some areas, flooding in others. Again, it looks like, and maybe even combinations of both. And again, the articles on Kentucky have talked about concerns about hydrological cycles here in this state. The concern about desertification due to drought, due to change, the shifting of animal habitats and patterns of animal migration, again, and decreasing biodiversity and potential extinction of many plant and animal species. All those things are tied to concern about climate change. any one of those has potential effects on animals and plants, but also has effects on people in those areas that use those animals and plants. And you may say, well, who gives a crap if Greenland warms up? Well, the people that live in Greenland, that may not be, may have very different cultures and very different values and very different, characteristics than us. They're still people, and they still, use their resources and their land, and they may even use it in a way that's much more ecologically sustainable than we do. But they're still going to be affected, right? And this brings in some concerns about environmental justice and about who gets the goods and who gets the bads. Then that we, in our place, with resilience of our systems, may be able to weather the changes that we cause, and other places may take them very much harder than we do. All right, so climate change discussions have often focused on these aspects of rising temperatures and sea levels. And again, there are going to be other effects as well. And I just laid out a number of those. We talk about surface temperature. Again, surface temperature consistently show increasing average air, water, and land temperatures to the point that as of 2017, 16 of the 17 hottest years on record have occurred since 2001. Since the time we've gathered data using thermometers, the hottest years have been more recent. There's a global pattern of weather and temperature variability. Our scientific evidence supports the argument that increased temperature is due to human activity. Worldwide greenhouse gas emissions, and this is just from 1990. This is just from the time that potentially, my daughter is born in '89. Right, so the lifespan 30 years. In the last 30 years, and this is even just the 20-year period here, increased from 35 to increased greenhouse gas emissions by 35%, by a third. Right, so it shows no sign of currently. Although we can talk about agreements that are being put in place and efforts to go carbon neutral or zero emission carbon, and if we do so, that'll be great on this problem, but that's going to require significant commitments from nations. It'll require significant commitments by business and industries, and it may well affect again the nature of our social structure, our culture going forward. And so it may, concern significant changes in our everyday lives, but it's particularly your everyday life and your children's everyday lives. I'm of an age that I probably will not see the major effects of climate change, on my life. I certainly acknowledge what's going on, but in some ways I will probably not experience it the same way that you will, and I'm sorry for that. I've tried to work in my life to stave off issues that would affect humans and animals and plants. And the more hands that work on it, the better off we are. But it's going to be a problem that you need to consider, right? As you make your choices. All right. Other things that are going to be affected: ocean levels, again, sea levels, salinity, acidity. We talked about that. Permafrost thaw is something we didn't necessarily touch on. The permafrost is an area it refers to a layer of Earth just below the surface that remains frozen all year round. And the large areas up north in Canada, Russia, other areas in the have sections of their countries where this is the situation. Even in the United States, in Alaska, we've got permafrost. So, so there's in the summers in those periods, that top layer might thaw, right? Maybe the top 3 inches, 4 inches, 6 inches might thaw out, but underneath that, it's been constantly frozen for a long time, for long periods. Climate change, as temperatures rise, and again in Arctic regions and Antarctic regions, temperature's risen higher than it's risen here. So 3 or 4 degrees change, and that 3 or 4 degrees is significant over the long haul. And in that permafrost is now thawing. It's no longer staying permanently frozen, and that's releasing. It's releasing a number of things. It's releasing because a lot of that has plant matter in it. So it can be releasing through decomposition a lot of carbon into the atmosphere. So it itself is now a source of greenhouse gas emissions. 1.5 trillion tons of carbon gas, including methane. Again, methane coming from rotting materials, which is being released at the rate of about 50 billion tons a year, and heats the atmosphere about 25 more. Again, that's methane, about 50 billion tons of methane, 1.5 trillion tons of carbon, and methane is more efficient at heating the atmosphere than carbon is. So it has potentially more an effect. It's also, there's been a lot of concern recently about the sort of microbes that might be living or have been frozen in the permafrost and are now coming back to life because they've been unfrozen. And so there's a concern about, again, increased bacteria that we may not have encountered or may not have experienced, increased viruses that we may not have experienced living in the permafrost and now being released into an environment that it hasn't been a part of for a significant time. And what are the likelihoods that new diseases are going to arise out of the permafrost? As we fight off the current disease that we're fighting, again, that becomes the new doom scroll, right? Concerns about sea ice and animal life, and again, the walruses, polar bears, being dependent upon ice for hunting and fishing, and for potentially for mating places, and the effects on them, the increased the changes that's brought into polar bear population, including polar bears dying of hunger and polar bears engaging in eating other polar bears to survive, interbreeding with grizzly bears because they can't find mates. All these changes coming to those species, and again, there are populations that potentially rely on walrus or rely on polar bears for food. That tend to be probably somebody that lives down the road from you, but there are certainly other cultures in our country, other cultures in other countries that rely on some of these species. So beyond their own inherent right to exist, right? The idea that polar bears have a right to live and to be a part of the world, or that walruses have a right to live and be a part of the world, beyond their own independent right to live, the effect that it has on humans' ability to use those resources, use them as resources, is affected. Right? Polar bears, they've considered polar bears as a threatened species on the Endangered Species Act. The problem is that there's no evidence that the Endangered Species Act potentially could protect them, because that would require that the Endangered Species Act be able to to stop climate change, to begin to engage business and industries and other things to stop climate change. And the Endangered Species Act was more about specific land uses or specific issues, like hunting. Like, oh, we can stop, hunting, or we could stop spraying DDT, or we could not build a dam here, because if we built a dam here, it would cause the species harm. Or the spotted owl controversy in the Northwest was about whether certain areas of forest could be harvested without damaging the ecosystem that the spotted owl lived in. Those are instances where you're taking aim at a certain human use of the environment to protect a particular animal species. It will require a much larger mandate for the Endangered Species Act to protect the polar bears, because it's not one person coming through and taking out a piece of their habitat. It's our entire human activity taking out their habitat. And so it's unclear that the Endangered Species Act can protect them. Again, with extreme weather, when people experience climate change, they're experiencing weather day to day. A lot of times we're seeing more frequent extreme weather events, stronger hurricanes, more hurricanes we've seen this year, stronger winter storms, more landslides, larger and more intense forest fires, larger, more intense heat waves and droughts and flooding. And again, as we spread out on the Earth's surface, as the size of cities increases, the likelihood that these events affect us increases, and the amount of damage they do increases. In the past, when cities were small and people were randomly spread over the countryside, and a tornado came through and would run over a piece of property, it had much less likelihood of hitting a bunch of houses. If you're the same area is now covered with suburbs, and a tornado comes through, you're much more likely going to hit people, because people are grouped together, but the bullseye's gotten larger, right? So what we see is an increase in these disasters, but also an increase in loss of life, an increase in the economic costs of extreme weather. And here they take off and talk about the summer of 2017 in the chapter, and about all the different natural disasters that occurred in that period and the effects there. And again, the experiences that we've had this last year with wildfires and with hurricanes, the book wouldn't even notice, because again, it was written a year and a half before. But we can certainly see continued large weather effects. And if we went through and put in typhoons or heavy rainfall or and looked at the natural disasters that occurred this year, I think we would probably see much the same pattern. Right? And we could talk about health and nutrition effects. Here you could talk about the death and injury due to extreme weather events. There are are the most extreme and most dramatic, but there are also other significant health events. So increased pollen. So there's been arguments about again, as plants have longer growing seasons, that they'll produce more pollen, so you'll have more ragweed, more trees, more plants. So that's going to increase allergy seasons and lengthen allergy seasons. You're going to have food supplies put in jeopardy by climate change. You're going to potentially again have more pests, as certain animals and insects don't die over the winter, and have longer seasons to breed in. So the natural carbon cycle has been altered. Even if all the greenhouse gas emissions are eliminated, those still in the atmosphere are going to warm us by about 6 degrees over the next century. And that's if we, even if we stop and got to zero emissions today, you're still you're still going to have this climate inertia. We're still going to see things get worse. I'm sorry for that. But anything we do today is going to shorten that climb. It's going to arrest that climb. It's still going to climb, but it's going to stop it from going even further. And potentially, it'll begin to allow us to stabilize sooner, right? And potentially even turn the trend sooner. But I'll stop here. We'll come back. We'll talk a little bit further about greenhouse gases and stuff. Hang in there. These are very serious issues we're talking about. They have very strong effects. They're things that we're going to be forced to live with, and that we need to work on. And we've got some solutions. And so one of the aspects of this is that we need to begin to get to the point where we can talk about some of those, or at least some of the mitigation and adaptation strategies. I'll be back shortly. Hang in there.